We're doing absolute value functions today. Okay, we're going to start off with the main guy, our parent graph for absolute value functions. This is the one that we're going to shift around, we're going to reflect, and we're going to stretch or compress. So if you know this guy, the rest of them are easy. We're just moving him around. That's all we're doing. Okay, so normally when we graph something new, we pick x values. Now the cool thing about absolute value is the absolute value of 1. If I plug in 1, what is the absolute value of 1? 1. But what is also the absolute value of negative 1? 1. So whether I go right 1 or left 1, I go up 1. Because the absolute value of positive 1 is 1, and the absolute value of negative 1 is 1. Okay, what is the absolute value of 2? 2. But what is the absolute value of negative 2? 2. Okay, what about the absolute value of positive or negative 3? 3. Okay, so this little table represents the moves we will do. Moves from the vertex of our absolute value. These are the same moves we're going to do every time. Those 3. On either side of the vertex. So it really makes 6 because we're going both sides. Okay, so let me grab a graph. Which graph do I want this time? This one? Oh, yeah, that's a nice one. All right, so here is our function. We're going to graph it right here at 0, 0, because that's where we start at the origin. And then what this table means, if I go right 1, I go up 1. Right 1, up 1. But the negative 1 tells me if I go left 1, I go up 1. And then plus or minus 2. If I go right 2, I go up 2. If I go left 2, I also go up 2. Now these are always moves from where? The vertex. So we always go back to our vertex before we start making this second move. Yes, ma'am?
How do we know it was 0, 0?
Well, if we plugged in 0 for x, we'd get out 0 for y. So with every parent graph, it starts off at the origin. Yes, sir? No, we're going to shift it in just a minute. So we're going to take this one parent graph and we're going to move it around. Okay, and then the next one takes us back to the vertex, and then we go right 3, up 3. Right 3, up 3. And then we go left 3, up 3. And an absolute value function creates a V. It goes V this way, and V, and the other side of V this way. My V did not quite connect. Let's see if I can shift that down to where it does. Nope, I missed. There. Okay. Now, that makes our graph. That's it. So what we do is we take this graph and then we just kind of move it around. We transform it. And that is the new part you're going to look at today. How can we move this around? So let's do our characteristics of this graph, and then we'll start moving it around. Do you see that this graph looks like it's going forever left and forever right? So what would the domain be? Negative infinity to positive infinity. But for the range, it doesn't go completely up and completely down. It has a lowest point right So it goes from 0, and then it goes up forever. Positive infinity. So range is your y values, bottom to top. So the lowest y value is 0, and then it goes up forever. Now, this vertex, which for the parent graph will always be at the origin, the vertex will always be a max or a min. In this case, which one is it? It's the min. So the min is our vertex, 0.00. Okay, now let's do intervals where the function increases and where it decreases. Okay, so if we started on this side of the graph, what do I do to follow along the graph? I go down. That first interval is decreasing. It decreases from negative infinity up to this x value. What's that x value? 0. And then it increases from that x value to forever. So it increases from 0 to positive infinity. All right, what about end behavior? As x approaches both positive and negative infinity, what does this function do? It approaches infinity. Okay, now here are two statements. Where is the function greater than 0? Greater than 0 is positive, right? And where is the function less than 0? That is where it is negative. Well, for this one, does it go below the x-axis at all? So it has no negative intervals. There's not any. It doesn't go down here. That's where everything's negative. Now, where it is positive, it is positive everywhere but at 0. Because 0 is not signed. We do not consider 0 positive or negative. So it's positive from negative infinity to 0, but we can't include 0. No include, parentheses. And then from 0 to positive infinity. So it is positive all the way to right there at that point, but can't include that point. And then it's positive over here, everywhere. So it's positive every place but that one little point. It is above the x-axis. Now, all absolute value functions will either be even or neither. Even or neither. There's no way to give them rotational symmetry. We can't make them odd. Now, if the vertex sits on the y-axis, it is even. If it shifted left or right any, it is neither. So the only way it can be symmetric to the y-axis is if that vertex is sitting on the y-axis. So is the parent graph odd, even, or neither? Even. This one, the vertex is sitting on the y-axis, it is even. Okay, so this is what you need. These notes are what you need, and now we're going to practice it with a whole bunch of different kinds of problems. It's neither if it shifts left or right. Yes, sir. Alright, so we're going to look at a whole bunch of different kinds today. see the whole thing. View. Let's go. View. Okay. Open this one then. No. Neither one of them want to open. There we go. All right, so let's do our first one, and then we'll just work our way through. Now, all we're going to do is take that function we just created, and we're going to shift it now. Now, if you remember from quadratics, if we have something added or subtracted to the end, this does the up or down. Now, because this is -2, this one actually means down 2. So all we do is we take that function we just learned about, and the vertex now goes down 2 units. So instead of being 0, 0, it's at 0, -2. But those moves we talked about don't change. These are moves from the vertex. So our moves from the vertex look like this. If we go right 1, the absolute value of 1 is 1. If we go left 1, the absolute value of 1 is 1. If we go right 2 or left 2, the absolute value of positive or -2 is 2. If we go right or left 3, so if I go right 3, I go up 3. If I go left 3, I go up 3. So these are moves. That sounded like a cow. Moves. From the vertex. Oh boy. It is Friday. Moves from the vertex. Okay, so these aren't changing. Same moves. All right, and then we draw in our nice straight lines. You guys can use anything that's straight. An ID, a ruler. Make nice straight lines. Well, the domain is still negative infinity to positive infinity because it still goes left forever and right forever. But the range changed this time because that lowest point moved. So what's the lowest value this time? -2. To infinity. Now make sure you use a bracket around the -2 because we can include it. Miss McCrary used to teach here and she said this is like a hug. It's included, it's loved. Alright, so this is always going to be a max or a min, and once again it is a min, so we have that minimum at the vertex.
Do we have
Okay.
to put the point?
You could say of y equals -2. Yeah, you could say a min of y equals -2 at x equals 0 is how I do it with my students. Or you could do the point. So remember, there are two that use the y values, the range and the max and min. Those are the ones where the y is the most important. Now, this uses x, 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 x. All those are the x. So these are the two where we're really focused on the y's. Okay, so do we see it's going up It's increasing from 0 to infinity. 0 to infinity. It's decreasing on this side as we move left to right. So it's decreasing from negative infinity to 0. All right, so the next one is my x-intercepts. Can you see them right there? What are they? It's probably easier to see on your graph.
2 and negative 2.
Very good. We have 2, 0 and negative 2, 0. If they ask us for an intercept, that is a point. So make sure you write it like a point and you put the parentheses around it so your teacher will give you full credit. Make sure you get credit for what you know. All right, and the y-intercept this time happens to be the same as the vertex. All right, in behavior, both ends of an absolute value will always do the same thing. Both ends. So whether we're going to positive or negative infinity, what are the y's doing? Going up. Very good. All right, this one, positive is up above. Positive is up above. So where is this one positive? Well, what was this x value?
0 or positive, negative.
Negative
0.
2. Okay, so it's positive from negative infinity to what that x value is, negative 2.
Oh.
Okay, and then it's positive over here from positive 2 to infinity. And then it's negative down here.
So then it's just negative 2, negative.
Yeah? Negative 2 to what?
0.
What is the x value right here?
Positive 2.
Yeah,
Is that it?
that is it. Oh, one last one. Is it odd, even, or neither?
Even.
Even. It is even because the vertex is still on the y-axis. Absolute value or either even or nothing. Yes, ma'am.
So, for like the one that's negative, like the less than 0, wouldn't you do 0 to negative 2 also?
It is in there. From negative 2 to positive 2 goes from here to there. Okay? All right. Let's do another one. You guys are going to do so good on this quiz next week. Oh, that's the next page. Silly me. All right. Go away. Page. Okay. It is still unloaded. Oh well. Alright. So this one. This has a number inside. A number inside is going to move it left or right. But you always have to do the opposite. The opposite of what's inside.
So, right.
So this one's right 3.
What do you mean by left or right?
So if we had like this would move it left 1. If we had this would move it left 2. If we had this would move it right 7. If we had this would move it right 3. So anything inside with the x. Well, x's are left and right. That's how we move left and right. So anything inside the absolute value bars with the x, we do the opposite of it, and that tells us how to move left or right. And I'll show you why this makes sense. We just said we go right 3.
Can you just say positive
Okay.
or negative? For that? Is that a left or right?
Sure. You go over right 3, which puts you at positive 3. Because what is 3 minus 3?
0.
0. Is that the 0.30? Yeah.
Could you do like equal? Can you do equal to 0 and you just add 3 in each time? So it'll be x equals 3.
You can, but we're talking transformations of functions, and like most transformations of functions are in this form, where the opposite of this moves the function left and right, and this moves it up and down. So the vertex is always HK. Do y'all remember that from when we studied parabolas? Okay? So with every function, and when you guys take the SAT or the ACT, they're going to talk about transformations. And it's going to look like this. They're going to say, how does that move the function? And you're going to be able to say, right, 3 units, because it's inside with the x. Or they might say, how does that move the function? It's because it's not inside with the x, it's outside. This is our up and down. So this would be up 2. Okay? Or they might put them together. I might say, how does this move the function? That would be right 1 and up 3. Okay? So we focus on quadratic in algebra 1, and now we're looking at other transformations, so we're looking at absolute value. So this moves it right 3. And then we do those normal moves. So from here at 3, 0, we go right 1, up 1, left 1, up 1, because the absolute value of positive or negative 1 is 1. We go right 2, up 2, left 2, up 2, because the absolute value of positive or negative 2 is 2. Then we go right 3, up 3, left 3, up 3, because the absolute value of positive or negative 3 is 3. And then you have your V. And it should look like a V.
Wait, why don't you right 3? Or did you just fill in the ones in between?
Okay, so we went back to those moves. The moves from the vertex.
Can't you just go like diagonal from that one?
That's not going to work as soon as I put a vertical stretch in there.
Okay.
Any number I throw out in front. Any number greater than 1 is a vertical stretch, less than 1 is a vertical compression. So we can have vertical stretches and compressions, and we can have horizontal stretches and compressions. In algebra 2, we don't normally do horizontal stretches and compressions with absolute value. Because it has the same effect as a vertical. Okay. All right. We're gonna go through and just make sure we can do all the graphs, and then if we have time, I may pick a couple to come back and do all the characteristics for. Okay?
Okay, with range, you're only using y, right?
So the range is 0 to infinity. Yep, just the y's. And this one is neither because we shifted it, right? Neither because we shifted it. All right. So I'm just going to snip just this part and make it bigger. Yes, ma'am. Okay, so where does that parent graph that we drew to start with, how is that one shifted? This tells me left 1, this tells me down 4. So left 1, down 4. left 1, down 4 tells me my vertex is right here. And then because it's an absolute value function, I can do those same moves from the vertex every time. So, right 1, up 1. Left 1, up 1. From the vertex. Right 2, up 2. Left 2, up 2. Right 3, up 3. Left 3, up 3.
Could you not be there till it crosses the axis thing?
Once you start drawing your line, I mean, it will cross. It's probably a good idea. I like that idea. Keep doing dots until it crosses the x-axis.
That's what Miss Linda was saying, like, people will do it and they won't like, stretch theirs all the way and then they say there's no x-intercept, but like, because they don't draw it all the way.
Okay.
'Cause eventually
I think
it
that's a
does
good
cross.
idea. Keep doing your dots
Or at least
until they hit the
line.
x-axis. Okay, so domain is always this. What is the range of this one, guys? -4 to what?
Positive.
To positive infinity.
So the range is for y. So if there was like no intercept that crossed the y, then what would the range be?
The range is always the lowest y value on your graph, whatever that is. And then if it goes up, it would be to positive infinity, and we'll do one in a second that goes down. So that one would be to negative infinity. Yes, ma'am.
So, do you always do that little chart with the like plus or minus 1?
You can always write it if you want to. I do it in my head because I know the absolute value of positive or negative 1 is 1. I know the absolute value of positive or negative 2 is 2. I know the absolute value of positive or negative 3 is 3. And because this is an absolute value function, that's why I'm taking the absolute value. Yes, ma'am.
So for the range, it's like the lowest y value, and then how do you find infinity for every?
Okay, because it goes up forever right here. That's what those arrows mean. It's going toward positive infinity. So anytime we have the arrows pointing up, positive infinity.
So when there are arrows, it's infinity, but it's like points where it stops.
But it's not. Like that one worksheet we had for homework in regular algebra 2 that was that little SE curve that had a stop and a stop. Yeah, that one was different. Okay, I want to do positive and negative on this one. Okay, so positive is up here. Up here. So positive is from negative infinity to what is this x value? 1, 2, 3, 4, -5. Then again, from positive 3 to infinity. Okay, and do you see that it is negative down here? Okay, what?
When socks don't
match.
Oh, okay.
I just looked down and I saw hers.
My socks are different colors.
Yeah.
I know. Actually, they're both the same brand, they just don't match.
So they feel the same.
Yes.
Yeah. I don't
I
like.
hate wearing the same socks.
Yeah, I don't like things to feel different. But I'm
I
okay
don't think
with
they
it.
feel different. Actually, one of them has a ring on the other one doesn't.
All right. So let's see what happens when we mix things up a bit.
What's the negative?
What's the negative?
The -3.
Wait for what?
No, which one's the negative?
I'll go back.
Previous
Just
one.
a second.
Okay.
-5 to 3. From here to here.
Okay.
From here to here. From here to here. It is negative. Okay. Now, I want you to look at this equation and plot your vertex. We're on the back side. We're doing that graph now. Look at the equation and plot the vertex.
Okay, so if I'm doing the X and Y thing, are they always gonna be like the same?
But there's also
It's always gonna be plus -1, plus -2, 1, 2, 3. So what is the point of that?
What?
Okay, you made us lean, so that's your this is first right.
So these are always your moves
that's
from
too
your vertex. Vertex.
It's negative 1/3 or negative 1/3.
no, but this is multiplying. When you add and subtract, oh, no, because you said add and subtract, it goes up and down.
So whenever you write.
That is multiplication.
So then it should be
George.
Wait, so then what?
I'm about to do it. I'm about to do it.
Okay.
Okay.
I want to find the right is the plus.
The range
Yeah, but it's not like plus, like that says like minus 3. That one minus 3.
No.
Okay. So, hopefully everybody plotted the vertex
Totally. I'm lost.
at 1, -3. Opposites, same. Right 1, down 3. Opposite, same. Okay, now,
So what do we do with the threes?
let's do it.
Okay.
Okay, these are our normal moves. 1, 2, 3. And that's what we do every time that there is not a vertical stretch or compression.
Okay.
When we have this leading coefficient, it stretches it. It takes each one of these and multiplies it by 3. So let's talk about what that does. Now, instead of going right 1 up 1, we go right 1 up 3. Left 1 up 3. Instead of right 2 up 2, we're going to go right 2 up 6. I made that dot too big and made it look awkward. Okay, and then I go right or left 3 and up 9. Okay, so over 1 up 3, over 2 up 6, over 3 up 9.
Okay.
Now, what you're going to notice is,
Just makes
Wait,
so
Miss
much more
Willoughby?
sense.
I go like all the way up until like I hit like the last one or something. Can I just do that?
sure,
Okay.
Miss Willoughby, that just made this so much more clear.
cool. And guys, what you're going to notice is the slope of the right side always matches that number. So if there's nothing out in front, it's an understood 1. So this slope is 1, 1, 1, 1, up 1 over 1. But when there's a number out in front, this side is positive 3 over 1, positive 3 over 1, positive 3 over 1. Okay, now we got to do this one because this is the awkward one. Okay, this one just has a shift right 3, but it doesn't go up or down. So the vertex is right here. But when I look at my normal moves, this time I don't multiply by 3, I multiply by -2. Now the negative makes it go down. The negative part makes it go down.
Go over 1, down 2.
Yeah. Over 1, down 2 in both directions. And then over 2, down 4 in both directions.
Can't you just do over 2 down with like, you don't have like start from the midpoint?
No, because this is the same as the slope. You could just count from the one before it, sure.
Okay.
It ends up being the same thing. Okay, so let's talk about the range of this one. This range is going to be different. Because this one opens down, when we go bottom to top, it goes down forever. So, negative infinity is the bottom, up to the top y value. What is the y value right here?
0.
0.
So it wouldn't be.
Wait, but does it get a bracket? Because it's not.
It does get a bracket because it includes that point. Okay,
Oh wait, isn't
is this function ever positive?
No.
No.
Pointing down.
It does not have any positive interval. Alright, so last one we're going to graph together is coming up. And this one's interesting.
Do you like go down, or you go up 1 and then half? Is that? Can you?
It's a half. So, over 1, up a half.
It's neither. Is number 2 neither?
Was the last one?
The last one is neither. Neither.
Because it can be odd.
Yep. It can never be odd. And the only time it's even is if the vertex is where? On the y-axis. Okay, so this one has, instead of a vertical stretch, it has a compression. So when we have a vertical stretch, our V gets skinnier, more narrow. When we have a vertical compression, our V gets wider. Okay? And you're going to notice that on this one. So because of the 1/2, because this is less than 1, it's no longer a vertical stretch, it's a vertical compression. And if we were to squeeze down on my hands, what would happen? They would go out. And that's what compression does. It compresses it. Versus a stretch, if you were to pull my hands up, they get narrow, they get smaller, closer together. So when it's a stretch, when it's bigger than 1, your V is more narrow. And when it's less than 1, your V is wider. Okay, so this V is going to be wider, but where's its vertex? Negative 1, 0. So opposite of this, nothing added to the end. That's where our vertex is. Okay, so this time, instead of going up 1, over 1 up 1, we go over 1 up a half. Guys, that's kind of harder to graph. The next one's easier though. Half of 2 is 1. So we go over 2 up 1. So if I were you guys, I might do 2 and 4 on this one. Because it's easy to take half of 4. What's half of 4?
2.
2. So I might go over 1, 2, 3, 4 up 2. Now, you're going to notice if you tie this in your brain to the slope, do you see I'm going up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And on this side I do the opposite direction. Up 1, left 2, up 1, left 2. So if you can tie those two things together in your brain, it'll make it easier when we have fractions. And there's a wider absolute value.
And it's neither.
And that would also be a neither. Most of them are going to be neither. The only time it's even is when the vertex is sitting on the y-axis.
That actually helps a lot.
Okay, so Your homework tonight in your regular math class is to do some of these problems and talk about their characteristics, okay? If you have any individual questions about any of the characteristics, I want you to ask about them now. If you don't, I need you to stay seated and stay quiet so I can help those that do have questions, okay? So now we're having 3 individual question times.